Hello, welcome back. The title of this lesson is Simplifying Radicals Involving Multiplication and Division, using the properties of radicals to simplify these. We just have a few problems here just to show a progression of, you'll see what I mean. I want to take the cube root of a number, the fourth root of a number, the fifth root of a number, and so you can kind of see the progression of how the solutions work out. Mostly just to give you practice with the exact same numbers, taking different roots of them and see how they work out and how sometimes the problems can look very simple, but the solution can take some time. The roadmap is, so far we've been dealing with numbers. This lesson will also be dealing with numbers, but after we do this lesson, the next lesson and the one after will be taking cube roots and so on, involving variables, expressions that have variables. So we'll be using the same techniques applied to variables in the next lesson. But for now, let's crank through it. What I want to do first is to do something pretty simple. Square root of 32. And then we'll take the cube root of 32 and so on, and then we'll do the same kind of progression with fractions. So how do we do the square root of 32? You all know this. We've done it a lot. 8 times 4 is 32. 4 is 2 times 2. And then 8 can be written as 4 times 2. And then 4 can be written as 2 times 2. So you see it's all a bunch of 2's. And since I'm dealing with and wanting square roots, I look for pairs. So there's a pair, and here's a pair. I have one orphan here. So this 2 comes out along with this one, making 2 times 2 on the outside. And on the inside, I have the single guy here. So I have 4 times the square root of 2. Kind of going fast through it because we've done this kind of problem a lot. Now let's go and take a progression. Let's say take the number and keep the number exactly the same, but see what happens when I take 32 and then take the cube root of it. How does it change things? Well, I can draw this factor tree over and over again, but it's the same number, so all of the numbers are going to be the same. Ultimately, all I care about are the bottom numbers. So to speed things along here and not do the same thing over and over again, I know it's 2 times 2 times 2 times 2 times 2. That's 5 of them. So it's going to be 2 times 2 times 2 times 2 times 2. That's the factorization of this thing, right? Of course, I could go through it again, but that's basically what it's going to be. But now I have a cube root. So I'm looking for triplets of things. I only have one triplet, so the one triplet comes out. Inside is going to be the cube root of what's left over, 2 times 2. So what I'm going to have is 2 times the cube root, go ahead and write it as multiplication here, of 4. 2 times the cube root of 4. All right, now look at the difference between these two. Square root of 32, cube root of 32. 4 times the square root of 2, 2 times the cube root of 4. I guess mostly I'm doing this sequence of problems to show you that as you increase the root of what you're doing, you can't quite predict what the solution is going to look like. Like there's no obvious pattern here. Or if there is a pattern, it's not something obvious that you would use as a rule. You have to work the problem out each time. I mean, you see 4 is multiplied by 2 to give me this, but then